Hey, welcome back to Fat Mama Physics. In this video, we are going to move on to multiplying and dividing polynomials by a constant, or just a number. So this and the next lesson are quite tied closely, because the next one, all we're doing is pretty much the same thing, except introducing some variables. And that's it. Both very short lessons in general. So, in fact, since the material, the ideas are relatively the same, the board game that I have that I will feature is, I'm pretty much going to use the same for both of these lessons, which aren't going to be very long anyways. And maybe for the second run, I'll just slap down an expansion of the game itself. Okay, so let's get started. Alright, so here we have the basic setup. It's there's no board, it's just cards. It's actually a very small game. It's a deck building game, and it's only played between two people, so great for someone like myself and my husband. There are variants where there allows more people, but this is called Star Realms. That's it. That's all you get. It's a deck of cards, essentially. Okay, so what is this game about? Of course, that other side didn't do a very good job with organizing, but essentially, it's a 1v1, you versus your opponent, and you want to basically take down all of their health. The first person to take down their health, the other person's health, is the winner. I believe that's the easiest. Yeah, that's yes. And everyone has 50 life points, 50 points, health points to start off with. I didn't organize that very well for the opponent. But anyways, essentially, how do you do this? You have a deck of cards that you start off with. This is your base deck. You got 8 of these scouts, which give you $1 each for buying things. And then you have 2 of these vipers. These vipers are the ones that can do damage. But of course, these cards are not very strong at dealing damage. Usually we like to scrap them or get rid of them. And anyways, that's how you do damage to your opponent. As those things. Okay, so we all drop our cards, and the first player to start actually only draws 3 cards to start with, and that's just because the first person buying has a lot of advantage. It has a huge advantage, because they get to see a fresh slew of 5 cards, which is not fair, so the other person who will draw up to 5 instead. So anyways, here are the things that you can buy. Here's some notice that every card, there are fractions. There's the blue fraction, there is the red fraction, maybe go closer up, and there's also a green fraction, and again, there's actually a yellow one. I don't know if I can grab that from the top of the deck, so there's also a yellow one too. So let's start with the top. The blue ones are the Trade Federation, the red ones are the Machine Cults, the greens are the blobs, so looks like bio-related weapons, ship-related, and yellow is Star Empire. Okay, so all of these have fractions. They're fractions. Your basic cards don't have fractions. You can always buy this other card in the that if you can't afford anything else. This also has no fraction. Okay, so of course you buy cards to get stronger and etc. So I'll play through one turn, and then I'll speed it up through a few turns into the game and show you what does this game have anything to do with multiplying and dividing polynomials by constants or monomials. Okay, so here I have 3 scouts. This is equivalent to 3 of the dollars. So I'm going to put this in I'm going to play 3 of these for $3. So I could buy a supply bot for just that one, or I could buy a Federation shuttle and a mission missile bot. Anytime I buy a card, that slot refreshes, so I get to see something else. I usually like to go with the Machine Cult fraction. That's one of my. This one lets you to scrap cards, basically get rid of your crappy cards, so you have a better chance of drawing your better cards. So it helps thin out your deck. I actually like this fraction, and out of all the cards, this is the only one that it makes the most sense and also gives you some sort of income. So I'm actually going to buy this, and I put that in my discard pile. and then when I end my turn, everything in my play goes into my discard pile. And of course, before that, this new card is drawn. So yes, I was very lucky. This newly drawn card is not as great for my opponent, but that's a risk that you run. If you buy a card, you run the risk of a really good card showing up and your opponent might snatch it out of you. So, and my opponent also has 5 cards to begin with, so he potentially could buy something that is worth 5. So that's also very dangerous. So anyways, that's one move. And since I had nothing to hit my opponent with, he has no defense, therefore that's it. That's the end of the round. So speeding this game up forward a few more turns, this is what it might look like. So here's a couple of turns in, and I'm starting to collect some fractions now. Fractions have a cool ability. They allow you to chain up their effects. So for example, if I had just played this card individually with no other green, or what's this called, the blob fraction, then I only activate the top effect, which is due to 4 damage to my opponent and scrap a card in a trade row. But if I play more than one, then the bottom effect also gets activated, and I need another green fraction card to do that. So this gets activated, and if I had this one, which I do, I activate this as well. Drawing cards are always powerful. So only the fractions, individual fractions, can activate its own fractions ability. You cannot cross-interact. The fractions don't interact with one another. So even though I have a nice base sitting here, he is a Star Empire fraction. He does not provide me with the correct symbol to activate the blob's abilities. Which is funny because my opponent is starting to collect Star Empire little spaceship ships. So they also have their own little abilities too that they can cross-activate. However, it's too bad they don't have a base, because a base stays there every turn, which is great, okay? But anyways, that's the idea, is that each fraction can only activate their own fractions ability and not not other fractions abilities. So that's kind of what I want to get at with these lessons, is the fact that only something that is similar to one another can be effective, or they can affect one another in some way, which I'll talk about what that looks like when we multiply and divide. Okay, so turn it back over to our lesson. Alright, so multiplying, dividing polynomials by a constant. So in this particular case, we have a number, and inside we have some kind of, some number of variables inside, and or numbers. When we do that, we need to use something called the distributive property, which hopefully you've seen before already. So this is kind of like review. And when we use distributive property, every single thing, every single term inside the polynomial is getting that constant, or is being multiplied by that constant, or divided by that constant. So in this case over here, notice that 4, and in brackets n plus 5, 4 needs to multiply everything inside the brackets, including every single term. So 4 times n and 4 times 5. So we're going to get 4n plus 4 times 5. So if you never trust how these methods work, give it a try. Let's say n is 1. If n is 1, then n plus 5 is 6. 6 times 4 is 24. Now if you did the distributive property method, if n is 1, 4 times 1 is 4, and plus 20 gives us 24. So math works. Distributive property works, okay? So here we go. You've seen the verification there. Now let's do a few examples, starting with B. So when you have a negative, same idea. You multiply everything that is about that constant with every single term inside. If that constant is a negative, or if it's part of a larger, if it's part of some long expression, even if it's minus sign, it's saying that that 8 is a negative 8, or you apply that negative sign, okay? So here we go. We apply it inside. We're going to get negative 8 times w plus, and in brackets, negative 8 times 2. And that's going to give us negative 8w minus 8 times 2 is 16. Next up is 5 times 8, and 5 times, don't forget the negative c. We're going to get 8, we're going to get 40 there, and 5 times c. And here's the thing, if you get a number multiplied by a variable, that 5, or that constant, is just going to go in front of the variable, becoming a coefficient. So what that means is it's almost as if I had 1 cup and I multiply that by 5, I now have 5 cups, so 5c, okay? And let's say we have a whole bunch of minuses and pluses. We just have to be very careful. Minus 4 times negative 5 plus negative 4 times a, giving us negative negative, that is a positive 20. And then here, even though this is a plus, I have minus 4 times a. That's going to end up as a minus 4a. Okay, so that is a distributive property. Now, I'm going to do one example where we're going to multiply a polynomial by a positive and a negative constant. So we're basically getting a bit more practice. So here we go. I'll do 1, you do 2. So here I have 3 times negative 2m, and then here I got 3 times 4. This is going to give me 3, and in brackets negative 2m, and then plus 3 times 4, so every single term there. And that's, if we're going to multiply that out, 3 times negative 2 is negative 6m, and I have 3 times 4 plus 12. Notice that only the numbers are affecting one another in this case. So the one difference compared to the previous example is that in the previous example, there were no coefficients in front of the variable. In this case, we do have a coefficient in front of the variable. And all you have to do is that the number treats the number inside that term. So the 3, I don't really do anything with the m. The m is left alone. The number 3 only deals with the number negative 2 inside that term. So in other words, it's almost as if the numbers deal with the numbers, and that's it. Numbers don't deal with anything else. And you're wondering, oh, but what about the previous example where you have to slap the constant in front of the c? Well, don't forget, there's always an imaginary 1 coefficient in front of any variable. So that's technically 5 times 1c. So again, the numbers interact, not with the variables. The variables are just the variables. It's something you don't know. The numbers can't do anything, cannot affect the variables. Okay? So that's just like how in Star Realms, in the game, where the fractions only affect their own fractions. They don't affect any other fraction. Okay? So it's like Gang Wars or something. Okay, let's do another example, and then maybe I'll pull up another example that I'll make up, and we'll do a harder one or something. So let's do B, but guess what? Why won't you try B? All right, good time to pause the video. Okay, so here we go. Let's apply this one here. I have negative 2. I'm going to multiply that to every single term, and hopefully at this point you're really good at figuring out what is a term and what is not a term, okay? So including the negative signs, okay, I'll include that positive sign there, these are all terms. So if I have to multiply this out, this is going to look like negative 2 times negative n squared plus negative 2 times 2n, and then in this case I'll do, it really doesn't matter. I can go minus, and in brackets negative 2 times 1, or I can just make that a positive and put that minus by the 1 as well. That works too. But probably this way is easier for you to interpret, so I'll leave it as is. So keep in mind, only the numbers interact. So there's a 2 here, and imaginary 1 here. There's a negative 2, a 2, a negative 2, and a 1. So only the numbers interact, okay? And including the negative signs. So I get negative 2 times negative 1. That's going to give me positive 2. I leave the variables as is, as seen here. And I move on to the next one. The next one here, the numbers interact with the numbers here. I get minus 2 times 2, this is going to be negative 4. So instead of adding negative 4, this is the same as subtracting 4n. Okay, I'm going to leave that n there. I just noticed I switched colors. Oh well. And then last but not least, notice I'm not going to put any signs here yet, but I'm going to get negative 2 times 1. That's going to be negative 2, but I also have a negative. Okay, so here let's write that out. This is negative, and then after I multiply this, I'm going to get negative 2 minus taking away a negative 2, it's like adding a 2. So this becomes plus 2 at the very end. Okay, so there you go. This is what it looks like to multiply a polynomial by a constant. So how about this? I give us a harder example, and then we can both give it a try. Okay, so here is my harder example. I think I made a little bit too hard, but I think we can do it. Well, remember, it's just taking things step at a time. And remember, if it's a number if it's a fraction in front of a polynomial, it is still a constant. You're still multiplying by a number, and the number always treats other numbers. So let's take a look here. If we have to break it down, this needs to be multiplying every single term. So that's what it looks like. And here we go. Let's identify the numbers, including its negative and positive signs here. And after doing that, we're going to get negative 2 over 3. That's what we're multiplying. We're going to multiply this by 3. Oops, let's change colors. X squared y in brackets. And then we're going to subtract, and since we're multiplying negative 2 over 3, we do that, and inside the brackets, this is 3y squared, okay? So this is what this is going to look like. Oh, and I forgot the number 3 here. So if we have to multiply the numbers together, and I made the coefficients 3 just so you don't have to do the math again. But let's take a look. Let's just deal with negative 2 over 3 times 3. Okay, let's do it as a side note here. Negative 2 over 3 times 3. Well then, if you had done it where you multiply fractions, then yes, this would give you negative 6 over 3, which then, hey, after you simplify, it's just negative 2. But there might have been a way for you to make your life a little easier. And yes, if you take a look at this 3 is being multiplied. Technically speaking, a multiplication happens at the top of a division symbol. So then 2 times 3, where 3 at the top is going to be able to cancel with one of the 3's on the bottom. So this, by default, after the 3's cancel, you're going to be left with negative 2. So that's a little tricky thing that notice here that these 3's are just going to cancel one another out. So these go away, these actually just go away, and we're just left with negative 2, and don't forget, only the numbers affect one another. The numbers don't deal with the variables. The variables we just leave, which is why I wrote a whole bunch of other variables, just to re-emphasize the point that the numbers treat the numbers, they don't treat the variables, okay? So there you go. So you have negative 2 xy, and here is the other one. Oh, don't forget, there's a minus 2 and another minus. This becomes a positive after you have 2 negatives. And there's only a y squared, therefore, it's just y squared. Okay, let me write that a little bit neater. This is going to look like negative 2x squared y plus 2y squared. So yes, please don't be afraid of variables, and it's okay to have them in your answer. It's just there, okay? That's it. You do the best as you can, and you leave your answer as is. So guess what? I'm going to break this video into a part 2 for examples 2 and 3 when we deal with dividing, and I guess some mixtures in the bottom too. So I thank you for watching, and tune in to part 2 of section 3.4 Fat Mama Physics, signing out.